welcome to the chemistry lectures, and in which I am presenting one of the most important process in the chemical reaction as well as in the life, and that is the oxidation and reduction. So oxidation of different materials, different chemicals, and then the reduction of different chemicals in nature, the existence of different compounds. That is because of the concept of oxidation and reduction. We know the different metals are obtained from their respective ores and minerals, where the different metals are present in their combined form, and that is in the complicated forms are there, and which are represented with oxides, something sulfates, the carbonate, the phosphates, borates, respective number of their compounds are present in the nature. Copper is present in copper carbonate. Iron itself is present in the iron oxide, that is the Fe2O3 or FeO, the ferric oxide and ferrous oxide, or the combination of the ferric and ferrous oxide. So here the concern is also regarding the organic compounds, where the organic compounds undergo the process of the oxidation. Here, whatever the glucose and the carbohydrates, the glucose undergo the process of the oxidation in presence of the oxygen. So that produces the energy. That is well known in our life. So we are taking carbohydrate, and carbohydrate itself, the polysaccharides, whatever the disaccharide, and then monosaccharide. So we eat food and taking the carbohydrate. The process of oxidation itself is there. So all of you are well known about that. The oxidation process inside our body, and that is the part of the metabolism where carbohydrate, the example fructose and glucose, those reacts with the oxygen. So that is the oxidation in the life sense. So why this oxidation is essential for us? Because that produces the energy, and energy is required. So we get the energy by the oxidation of different carbohydrates, and different carbohydrates which are present in the form of uh, monosaccharides or disaccharides or the polysaccharides. If suppose we have the fruit juice and in that sweetening is there, so that may be the carbohydrate and maybe glucose or fructose. So in various foods, so that is the carbohydrate also present in different quantities, different proportionate and different foods. So whatever the food may be, the vegetables or non-vegetable or the seafoods, whatever that. So the question is there, the energy is obtained after the oxidation of carbohydrate. So that is the life concerned with the life. So life is also related with the oxidation and reduction process. One more thing is there, how the carbohydrates are formed, and I think all of you know about the plants. And in case of the various plants, one of the photosynthesis process is there. So with the help of photosynthesis, the carbon dioxide combined with water and forms the carbohydrate. That is in the form of the starch. So later, what they are using the carbon dioxide. So further, we can say the oxidation and reduction are the whatever the parts of the reaction in which, if both occurs, oxidation is also, then the reduction is also. In case of the titration, the experimental concern of the practicals, where the reduction and oxidation, redox reactions are to be handled with the help of the titrating method. So analysis of different compounds with the help of reduction, oxidation, titration. So where in that particular case, the what we have, we can get the reactions, and those reactions are related with the reduction as well as the oxidation. So today we discuss about the inorganic compounds, about the organic compounds. The process and the reduction and oxidation are relevant for their different fulfilling of the reactions. Even our life is also controlled by the redox reaction, where something there may be the reduction, there may be the oxidation. Even one more thing is there, the oxidation helps in the destruction of those particular organic matter. So, for example, if suppose we have the any of the organic matter that is present openly, so oxygen is added. So I think the common process of oxidation is the addition of the oxygen. So we can see the oxygen O2. Here O2 and H2. H2 hydrogen. Hydrogen gas H2 and O2 itself is the two oxygen atom, and basically the chemically oxygen O2 is the gas, hydrogen is the gas. Now we can say the fundamental electronic configuration of oxygen, atom number 8, electronic configuration 1s2, 2s2, 2p4. So 6 electrons are in their outermost shell. So that's why we can say that 6 electrons are there. So uh, one more thing is there, and that is the octet rule. All of you know about the octet rule. So octet rules means the 8 electron must be there in the this one. So here oxygen is divalent. So O2 is formed by the whatever the combined with 2 electron from here. So octet of each oxygen is completed. So now the oxygen itself is added, and for example, if suppose we have the metal, uh, the sodium. So sodium reacts with the oxygen, then sodium oxide will be formed. So what happen? The electron transfer in case of the sodium to sodium oxide. So here addition of oxygen, this is the commonly called the oxidation process, and reduction, addition of hydrogen. So we have to see how these fundamental chemistry itself is involved in the different complicated reactions and complex reactions of human being. In case of the human being, the whatever the cell and they are the energy, they are the hormones, they are the enzyme activities, all those concerned with the electron transfer. So based on the electron transfer, oxidation and reduction can be also explained. How electrons are changed, and fundamentally, basically, when we see the periodic table, in case of the periodic table from left to right, the increase in the electron, and the valency also can be arranged for that. For example, in case of the group 2, so group 2, we have the alkaline earth metal. Group 1, we have the alkali metal. So from the top to bottom, there the atomic size, there the oxidation number is what we have from in a group. And when we have the left to right, and that is the period. So when in a period we go from left to right, so what happen in case of that left to right, certainly there the valency itself varied. What happened in case of the p block element when we have the period number 2, where the we lithium beryllium. Okay, that is the period number 2 from left to right. So here left to right, lithium beryllium boron. So boron, then boron having the 5 electrons. After boron, we have the most one is the carbon, hydrocarbon, organic compound. And that is the 6 atom number 6. 7 nitrogen, 8 concerned with the oxygen, 9 with the halogen part, and that is the fluorine. And atomic number 10, that one is the neon. So here oxidation, how this can be happen. For example, in case of when we go towards the 3p series, 3 period, sodium. So sodium have the characteristics. So what happened to the sodium? Lose the electron easily. And in case of the chlorine, 7 electrons, the fluorine, the 7 electron outer shell. In sodium, the 1 electron in the outer shell. So what happened? Sodium lose 1 electron, whereas the chlorine take 1 electron. So lose of electron itself, the term de-electronation, and addition of electron, that is the electronation. So on the whatever the concepts of the oxidation and reduction, here the concept of oxidation was the addition of the oxygen, and reduction is the addition of hydrogen. So here let's we have to see the oxidation and reduction process that is very important in our life and the life sustainability, because so here we have the concepts of the oxidation and reduction. We have explained whatever we have discussed about the electron transfer. Here basic concept, addition of oxygen and addition of hydrogen. So now oxidation in which oxygen is added, reduction in which the hydrogen is added. This is the simple example. This is the common concept. Addition of oxygen, oxidation. Addition of hydrogen, reduction. So later on we can see in case of the inorganic compound, there is if suppose iron plus 2 undergo the process of the oxidation towards the iron plus 3. So that is the oxidation. So here the role of the electron. So what happened? I am 1 electron from ferrous is removed, and Fe plus 2 is converted into Fe plus 3. So that is the oxidation. Whereas if suppose we have the copper plus 2 ion that is present in electrolyte. So copper plus 2 is converted into the copper 0. So what happened? Electrons are added. So that is the reduction reaction. Oxidation reaction, electrons are removed. Reduction reaction, electrons are added. Reduction, hydrogen is added. Oxidation, oxygen is added. So therefore we have to see there may be the redox reactions occurs. Why redox reactions occurs? Because we have to see because of the one time when oxidation occurs, then simultaneously there may be the reduction. So such reactions called reduction redox reaction. The very well known example in the titration. So what we are doing, the ferrous ammonium sulfate itself is titrated against the potassium permanganate. So that is the well-known redox reaction. So well-known redox titration. Then the strength and equivalent weight of oxidizing and reducing agent. So here, for example, the ferrous ammonium sulfate itself is titrated against the potassium permanganate. So what happened? Here ferrous ammonium sulfate, the iron plus 2 is present in the chemical, and that undergo the process of the oxidation. So here oxidation occurs because iron plus 2 is converted into the iron plus 2. So that is the oxidation. Whereas in case of the potassium dichromate, the titration between the ferrous ammonium sulfate and potassium dichromate. So in case of the chromium itself undergo the reverse reaction as compared with the ferrous to ferric. So what happened in that particular case? And definitely there is the electronation. So because of the electronation, then the process is the oxidation. So now Their strength, their equivalent weight also correlate the number of transfer of electron, how electrons are changing. So that is the particular, we can say something, if oxidation occur by the chemical, so that is the oxidizing agent. And something reduction occur, that is electron are added. So that is the reducing agent. So what about the role of agent? To push the reaction, to support the reaction, and that's why these are the oxidizing and reducing agents. So ferrous ammonium sulfate with potassium dichromate. So here the reverse will be reducing agent and then oxidizing agent. Theory of redox titration, that is based on the electron transfer, and something there are the redox indicators. Because of the indicators, any of the titration we can check this particular with the help of the indicator. Here the redox titration and phenylenthranilic acid. And phenylenthranilic acid, this is used as a indicator. One thing, there may be other are also used as a redox indicator. Then the cell representation, this is the well known, because when we have the cells, so they definitely there will be, in that particular case, reduction or oxidation occurs. So redox reactions are also important concern with ourselves. Now we can say that can be correlate with the types of cell, whatever those can be. Then the corrosion occur because of the oxidation. Then how uh, electrode potential can be measured. So oxidation reduction curve, iodimetry, and iodometry. These are the where the redox reaction occurs. So next, the titration involving other examples: ferric sulfate, potassium iodate, potassium bromate, potassium permanganate, titanium chloride, sodium 2,6, dichlorophenol, indophenol, platimar, and Paul Brex diagrams. So here application of redox data in the extraction of this is also how the metals are extracted from natural occurring minerals and ores. The simple example, how we get the iron. So iron, this can be obtained how? From the minerals and ore. So oxide, and that oxide is the metal oxides. So metal oxides, whatever the iron oxide. So hematite is one of the example of the mineral, and that can be converted. Hematite itself is the oxidative material, where whatever that are the oxides. So oxides are there. So let's say we have to see the whatever there may be the changes. So this one, and the common one, oxidation and reduction reaction, whatever we are discussing, uh, that particular how oxidation occurs and how reduction occur, and what are the conditions responsible, and those responsible conditions are to be discussed. What are the important conditions are required for the this such type of oxidation and reduction? Even we can use the different indicators in the internal indicators are also used. So why that is depend on the conditions. So conditions are what? The better condition must be there. So oxidation reaction occurs, and oxidation reduction, the commonly they call the redox. So redox is a chemical reaction involving transfer of electron between two species. This is the fact. So what happened? Oxidation reduction redox is a chemical reaction involving a transfer of electron between two species. And oxidation reduction reaction is any chemical reaction that we have discussed many times, where the oxidation number of molecule atom on or changes. So oxidation numbers are changed by gaining of electron. So by gaining or by the losing on electron. So this is all what is the basic concept behind the oxidation and reduction that I can clearly so here one more thing is there, how this redox reaction will be there. So oxidation reduction definition we have already discussed. Oxidation reduction redox. So redox itself where reduction and oxidation both occur. So any in oxidation reduction redox reaction is a chemical reaction involving yes. So chemical reaction involving transfer of electron between two species. That's we have. The electrons are transferred. How these are transferred? Anyone? Why the such elements undergo the process of the transfer of electron, while the some elements wants to take the electrons. So that is the transfer of electron between the two species. An oxidation reduction reaction is any chemical reaction. Now, you can see any chemical reaction where the oxidation number of molecule or atom or ion changes. So how this can be changed? The simple electron transfer, electrons can be gained, electron can be lost, but need that is whatever that particular thing is the uh, oxidation number of a molecule, atom or molecule ion changes by gaining or loss of electron. The redox reaction are very common and vital to the basic functions, whatever I have mentioned. And what are the basic functions? So, particular. So, using in process such as photosynthesis, whatever I have discussed, the photosynthesis, respiration for ourselves, then the combustion process, combustion of the whatever those are the fossil fuel. So combustion of fossil fuel is because of the oxidation, and here the photosynthesis that is also the example of the redox reaction. So redox reactions are very common and very fruitful, the vital basic function, life supporting, and using the processes. And what about the processes using such as the photosynthesis? What happened in the photosynthesis? Anyone? What are the workforce and where the starch is manufactured in the company of the plant? So certainly, the redox reaction are very common and vital to the basic functions such as life using the process and photosynthesis, one of the process in which the carbon dioxide as well as the undergo the process of react with the water and form the starch. So that process is commonly in case of the whatever we have to see and very well known photosynthesis. CO2 plus water gives the starch. Production of the food by the plants. Very interesting and magically how the plants converts the non-living seed. Why non-living? Because no optimization is there, not to. So is similar here. So many natural reactions are there, including the respiration. So respiration for ourselves. What is the respiration? We take the oxygen. From we take the oxygen from the air. And if suppose one of all of you can prepare some projects, and those projects find out the problems related with the redox reactions. So what are those here? The different respiration good supporting for ourselves. Because of the respiration we get the energy, and our movement is the continuously following combustion. Combustion means whatever the destruction of those organic material, those organic compounds, and this is well known in the petrol and diesel. So petrol and diesel highly used by the petrol and diesel vehicles. So now we can say the last one and the redox reaction are very common. Common means a number of chemicals are so very common, and in this particular case, chemicals, important value of the chemicals for everywhere, whatever different organic supply, organic compound suppliers that we have. This one is the whatever that is the photosynthesis and combustion of petrol and diesel, where oxygen itself is. But in the present case, whatever the last 2 months, in case of the April, and that was the whatever the pandemic situation, and oxygen was required. So oximeters were there for the corona patients. So that is the oxidation. So we need the oxygen for the whatever that can may be the liver, whatever that may be the skin part. So all must be. So this is very interesting. The reduction and oxidation process. Now we can come here the simple way, oxidation and reduction. So what we have to see that reduction increase oxidation number. This is the question. So whether whatever we are discussing about the so oxidation involves an increase in the oxidation and decrease. The another word whether this can be increase or the decrease. So decrease in oxidation number. How we can calculate the oxidation number? That is the very simple, but because we have to see the final when the pandemic situation there, so decrease in the oxidation numbers. So what happen if electron is added? Electron is removed. Oxidation when occur? Iron 0 undergo the process and Fe plus 2 is obtained. So that is the more or the usually the changes in oxidation number is associated with gain or loss of electron, but there are some redox reactions, and those redox reactions in covalent bonding also, and that do not provide any of the electron transfer. So we can say uh, oxidation and reduction, electron transfer, electron gain, electron loss. This is the thing. So let's say we have to continue for that next one. So usually the changes in oxidation number associated with gain or loss of electron. But there are some redox reactions, covalent bonding, and that do not involve electron transfer. So that is the electron transfer. Now, oxidation reduction reaction can be explained in different four ways also. And what are those particular ways? Those are the in terms of the electron transfer. So electron transfer itself is mostly whatever the changes in the material, whether electrons are lost from the material, whether electrons are more in the weather. So electron transfer in the base explained by four ways: oxygen transfer, addition, hydrogen transfer we have discussed. In term oxidation number, ferrous plus 2 charge, and that is converted into the plus 3. So that is the oxygen oxidation number. Is redox reaction overall. Number of examples are there in the life related activities. Now, what we have. This is the one of the process, and we get how we get copper plus 2 converted into the copper plus. Copper plus, not the plus, copper 0. So reduction by gain of electron. What do you mean? If electrons are added, So definitely that project, that one is what we have, the reduction. What the opposite will be the oxidation. So gain of electron, electrons are added or whatever that particular, this is the oxidation. In case of the that is the reduction. In case of the oxidation, opposite to that, and loss of electron. So what happened in the losses of electrons? In such conditions, the whatever the copper plus 2 is converted into the copper 0. So oxidation number of copper is plus 2 because that is mentioned in the slide M. So plus 2 is itself is there. So copper plus 2 is converted into the copper 0. This one happened. So what happened? Gain of electron. In case of the magnesium plus 2, and that converts the magnesium fluoride. So now, and this is the gain. Someone get the profit, someone get not. So gain of electron, and where from where get the electron in the space, the compounds, the so that is the case. Here the magnesium undergo the process of the oxidation by loss of electron. So because of that loss of electron, copper plus 2 undergo the process of the reduction also. So oxidation and reduction both are there. Why? Copper plus 2 and magnesium itself, and both reacts and then gives the so electron behavior. So importance and that electron behavior is also correlated with the oxidation and reduction. So now we can say one more oxidation reduction in the chemistry. So different examples are there. We have discussed already. That particular, this is one of the oxidation reaction. So what happened? We can say I have earlier discussed about that organic compounds are also undergoing the process of the redox reaction. So what happened in case of the oxidation? So oxidation, organic compounds undergo the process of the oxidation. So how the present compound, whatever the compound itself is given, CH2 double bond CH2. These are related with the organic part and related with the whatever the organic values. So organic compound, hydrogen is added. What about the reduction or the oxidation? So CH3, CH3. So therefore, you get the compounds undergo the process, then oxidation occur, reduction occur, addition of hydrogen is the reduction, and removal of oxygen, addition, that is the removal of. So here also one of the spiro compound. What are the cyclic compound? Cyclic compound ethylene oxide. So here also the process of the reduction occur. Reduction means electrons are added. Oxidation means the electrons are removed. So here in case of the reader and product, and we get that particular ethylene is itself is obtained. So this is the reduction. So how this can be reduced? So that is given in the picture oxidation. So now there are some of the questions. Those are related directly with the corrosion also, the electrochemistry also, but overall related with the fundamental, and that particular fundamental can be we have the axion. So here, which of the following is the overall reaction of rusting? You can find out. So there are the options are given. So first option, iron. Iron is converted into iron plus 2. Whether this is, what about the rusting? So what happened? Next, oxygen, and oxygen combined with the hydrogen atom, and then this oxygen undergo the process and conversion into the water. Then we have the iron. Iron itself, the iron in presence of oxygen, 4 of hydrogen are given, So whatever that particular different reactions, and so answer correct answer for the resting is the Fe plus oxygen plus 4H. 4H means here the aqueous condition, which gives the S, but the S. So here we can see the correct answer is the C, where the Fe plus Fe plus is converted into the Fe plus 3. So let's we have the answer for that. And next one, this slide is also relevant with the explanation for that. Iron undergo the process, and this is converted into the respective oxidized product, and that is the iron itself is converted into iron plus 2 and 4 electron. This is the reaction that occur at the anode. One more thing is there. The anode, and anyone have the idea about the anode and cathode. Cathode, the relationship with the cation of that particular. So reduction and oxidation. So here, what we can get the fundamentally oxygen reacts with the 4 of hydrogen atom, and then 4 electrons are used, and finally get the reaction. So here the reaction occurs at the cathode. So now there are explanation behind this. Iron plus O2, this in presence of hydrogen positive, and that is converted into Fe plus 2. So let's we have see the different things and the importance of the oxidation reduction in our life. Another example itself is the oxidation. Whatever that can be the flow, the conductance, and electrolytic conductor. Here also relevant with the oxidation and reduction. So what happen if suppose iron plus 1 and that goes to inside. So iron plus 2 having the what are the conductances. So in electrolyte conductor, the conductance is due to. We can see the answers: flow of electron, mobile, free electron, one thing, the movement of the ion, either movement of electrons or ion, those cannot be said. So that is the D answer. So correct one, B answer, explanation in metallic conductor. Whatever those particular metallic conductors, so in case of the metallic conductor, uh, that they exhibit the conductance. And most conductor, I think that is the aluminium. So now oxidation in aluminium, whereas the oxidation in copper, oxidation in the. So in metallic conductor, the conductance is due to the flow of electron, mobile electron, and in electrolyte and conductor. Next question, an electrochemical cell generally consists of a cathode and an anode. So with which of the following statement is correct with that respect to the cathode? Correct. Oxidation occurs at the cathode, and electrons move into the cathode, usually denotes by the negative sign. Is there is difficult. There is usually made up of the insulating. The correct answer is the B. Electron moves into the cathode. So that is the supports specifically, and the answer correct answer is the B. Now you can see the another question, and that question is related. Which of the following factor does not affect the electrode? Here, what are the electrodes and electrode potential? So electrode potential of which one? If suppose we have the copper plus 2 is converted into the copper 0. So uh, so what would we have to see the factor affecting the electrolyte potential of electron. So here the correct answer is the size of the electrode. First of all, the nature of electrode, one thing, Okay, uh, that affects temperature, the temperature variation, molarity, and that is the size of electrode. This will be the correct answer. Electrode potential is the tendency of an electrode to accept or to lose electrons, and electrode potential can be electrode potential depends on the nature of the electrode, which type of electrode is used, and temperature and the solution and in the concentration. So temperature, concentration, and whatever the nature of the electrode, those are responsible for to get the relevant information. Temperature is also one of the concern. So I think all of you have one more. So we can say start from the oxidation. So oxidation, this is very simple, and various electrochemical reactions which are also related with the whatever those can be related with the electron transfer. So with the electron transfer, what we have, whether electron is added or electron is removed. So addition of electron, here we can say the overall reaction of rusting itself is the C1. So where the iron plus 2 in the form of the solid and oxygen in the form of the gases and hydrogen cations. So hydrogen cations, the acidic medium, thus gives the respective twice of Fe2 plus, and this one is and twice of H2O. So which of the following is the overall reaction of the rusting? And the correct answer is the C. So let's we have another examples whatever we can explain different examples, even the most one we can in the organic compounds. So what happen, the organic compounds oxidation and reduction. So oxidation, here we can say the hydrogen is added. So what happen here, the question is the carbon double bond carbon. If suppose carbon triple bond carbon, so that will adhere, then the hydrogen is added. So process, the addition of hydrogen itself is the reduction. So what about the oxidation, where either hydrogen is released? So when we have to see the backward reaction, backward arrow, here the oxygen, we can say that is the oxidation one side from the right to this one. So here remove two things are there: addition of hydrogen or removal of hydrogen. So removal of hydrogen, then definitely what happen? If hydrogen is removed and in hydrogen is added. So in that particular case, if addition of hydrogen gives us the saturated compound, so that is also important. But slowly they can get to information, and that will be the oxidation. So reduction and oxidation, those are most important. So these there are certain examples. Whatever the one more thing is the electrolytic conductor. So electron transfer itself. So therefore electron transfer itself is also the example of the electron and so let's we have to see the different aspects of these electron transfer, and electron transfer itself is related with the oxidation. Even most value addition in the oxidation reaction itself is the use of the batteries. So batteries, definitely electron transfer. Chargeable battery we are using, we are charging the laptop, we are charging the mobile phone. So with the help of that particular specific is the whatever we can have the battery, involvement of the battery. So electrolytic, the present context, the vehicles. So electric vehicle, that is the main thing is the electric battery. So that battery is relevant with the that is that relevant the technology. We can use if we have the mobile phone and that mobile is charged. So definitely when we are charging, so that is the whatever that then in the electron are responsible for the charge, and when we are consuming, the electrons are responsible. So therefore, uh, one side the oxidation where oxygen is added, and another side there will be the reduction where oxygen is so two things are there. Oxygen is added or hydrogen is added. Oxygen is added, the oxidation. Hydrogen is added, the reduction. The reverse of those also, those are the same thing. Now, in case of the electron transfer, whatever there are so many examples, and in case of the electron transfer, what happened? That particular electron transfer, de-electronation and electronation. So de-electronation, removal of electrons. That is the aspect, that is the concern in the different modern technologies uh, which we have to develop, and those the battery technology and where reduction and oxidation is there. So who is the responsible? So therefore, there must be innovation in the organic in the oxidation and reduction by which we can definitely we can imagination can be converted into the respective answer. So thanks for all. Here the oxidation reduction one is the important concern of the life also. So okay, anyone have the query, he or she can ask me whatever the name itself is given, the name after that I have the mobile number is also given, and then we can have if any one then mail id is also there. So all are welcome to ask any of the queries, and that you can get even the where there may be the very simple queries or hard queries, so you can ask me uh, any of the question. So I suppose that you will get the more and more relevant informations related with the oxidation and reduction. So today's that is the all, and that one concern about the